Hey guys, what's up? Welcome to TSK Tutorials, and this is RZtuts2, 2 of 5. So this is the second of 5 videos going over how to teach you how to create totally badass bullets inside of Unity3D. So in this episode, we're going to be jumping into JavaScript and learning how to create the basic script outline of how these bullets are going to work. So this is probably going to be the most amount of code that we're going to be going over for this particular episode, but it's probably going to be the simplest code that we're going to be going over. The most advanced thing that I think we're going to be using is an array, and physics.raycast_all, I believe, is the function we're going to be using. Alright, so basically the way these bullets are going to work is they are going to kind of fake physics, so we're going to be creating our own physics. So basically what we're going to do is in the very beginning, so inside of function awake, we are going to set a variable, which is, let me see what I called it. I called it move direction. That was the name of it, move direction. So we have a vector3 called move direction, and basically this is an x, y, and z variable that's going to determine what direction our bullet is moving and at what speed. And then we are going to every frame modify that and add some gravity to it. So instead of it just moving in a straight line at a constant force, it's going to kind of arc, and it's going to have some gravity to it. And then also in the very beginning, we're going to add some randomization to this. And you might think that, oh, well, that's really easy. All you got to do is you create a variable that is a float variable that determines the random amount x and x and y, rotating around the x and y axis. So that would give you a random amount like this and a random amount like this. And you might think that that is what you want to do, but really no, because what that is going to do is that's going to give you kind of a random square area, because it's going to randomly go rotating around the y-axis like this, and it's going to rotate randomly around the x-axis like this. So then basically what you have is a random square area that the bullet can land in. So what we are going to do is we're actually going to, I believe it is around the x-axis, or maybe it's the y-axis. Either one, it should work the same. What we're going to do is we're going to randomly have it go, let's say x-axis. We're going to add some randomization around the x-axis, and then from there, we are going to rotate it around the z-axis by a random amount of 360 degrees. So that means that we have a random amount, so we have basically our diameter of the random circle that we want the bullet to go into, and then from around there, we rotate it in a random 360 degree pattern, and then we have a circle of a random area that the bullet can go into. So usually this isn't that big of a deal, especially with, like, say, like an automatic gun or even like a pistol or something like that, where you won't really notice that it's a square. But this makes a big difference if you're going to be firing off, like, say, 10 of these bullets at the same time. Like if you have a shotgun and you want to shoot out a bunch of bullets at the same time, you're going to kind of notice that they sort of go in a square pattern. So if we just mix up these numbers randomly around the x and z axis in a random 360 degree pattern around the z axis, that gives us a nice circle, and that's much better for shooting bullets randomly, especially with a shotgun. What else are we going to be going over? One second. I have the script on the screen over here. Then we are going to go over, let's see, how to create a bullet hole, sort of. The bullet hole are basically going to be the exact same bullet holes from my other tutorial playlist, FPS1, but basically it's just a 2D plane that we have. It's just a game object prefab that we're going to instantiate, and then we are also going to learn how to make this bullet hole we're going to set its parent to whatever game object it hits. So if it hits a game object that moves, such as an enemy or a rigid body, it will stick with that object, as opposed to just landing right there and then floating around in 3D space while the object moves and then it stays stationary. It will actually stick to the object because that's where the hole is in if that object happens to move. What else are we going to be going over? We went over random blah, 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 blah. I think that's pretty much everything that we're going to be going over in this episode. So why don't we cut the camera and go into Unity and learn how to do this inside of Unity. Alright, so here we are inside of Unity, and this is where we left off in our last episode. We created this bullet that you can view from any angle, and it will look cool like that, and there's an inner and outer no matter which way you look at it. So we're going to be attaching a script to this object, which basically just when this object is created, and I forgot to turn Steam off. Let's close. Oh wait, no, that's Unity. Crap. What the heck? I thought Steam. Where? Alright, exit Steam. Alright, now we won't get those anymore. Alright, so let me reopen up Unity. Way to go, Etiski. Alright, so anyways, so we are going to create a script and attach it to this object, and basically what it's going to do is whenever this object is first created, it's just going to make this bullet fly forward and have gravity to it and just keep on going until it hits something in the level. So let's go ahead and take a look at first the gun script. So here we have the gun script, and as you can see, there's a ton of code that we can't go over in this episode because there's simply way too much. So no matter what your gun script looks like, we're going to put the line that we need in your gun script right here. So wherever that may be in your gun script, or if you want to create your own gun script, basically the way it's set up is we just have a transform called bullet spawn, or a game object called bullet spawn, in which we save the transform and reference its position and rotation. So we know the position and rotation to instantiate the bullet. So this is a line of code that we're going to use later, but for right now we're going to create a simpler line of code, and it's just going to be wait, I hate the word instantiate. Instantiate. And then we are going to save it inside of a variable called, let's just call it bullet. Is that, yep, bullet's not taken, so we'll just use bullet. And we'll do bullet spawn, which is a variable which we already have. Dot transform dot position, and then bullet spawn dot transform dot rotation. Alright, and we're going to need to create the variables, but basically, we have an instantiate function which is going to instantiate a prefab which we're going to save inside of a variable called bullet. And then we have a variable called bullet spawn, and this is going to be an empty game object which is a child of our gun, which is going to represent the position and rotation in which we want to spawn that bullet. So let's go ahead and create the variable bullet outside of our update loop, and let's try to keep it somewhat organized and find all of my other bullet stuff, which it seems to be extremely scattered around, so I'm just going to put it at the bottom of the list here and just call it var bullet game object. Okay, and it actually probably would have worked better to make it a transform, but using a game object also works. So now let's go back into Unity, and I want to do this for the shotgun. So let's go ahead and pull a shotgun out, which we have right here. Let me pull that up so that you can see it. Let me focus in on the shotgun. Okay, whatever, good enough. So here is our shotgun, and the gun script attached to the shotgun, and then we have our bullet spawn set up, which is right here, which is actually way behind the gun, which the reason why I have it way behind the gun is so that if the bullet spawns behind the gun, if your gun is actually going through something, like let's say you're standing really close to a wall and your gun is going through the wall, but you're using the camera trick to make it look like your gun is not going through the wall, which is a standard first-person shooter camera trick, then it makes it so that, like, say if it were to spawn here and your gun is going through the wall, your bullet would spawn inside the wall and shoot through the wall, and we don't want that. So that's why we spawn the bullet back here, because you can't really tell that much where the bullet is spawning from. So the way that we had it lined up was that, like, originally let me zoom in more on that. I had it originally just in this position right here, right in front of the barrel, and then I just drag it along the Z-axis and put it back there like that, so that we know it will shoot through the barrel and we will still have an accurate shooting gun. Alright, now let's see. The next step, I guess, is that we actually want to save what the bullet is that we are going to be spawning. And the variable is going to be all the way at the bottom, which right here is bullet, and it says none game object. So let's create a prefab, and I guess let's, if I right click right here and I click right click, create prefab, yep, there we go. We're going to call this, I guess we can just call it bullet. And let's see, how is this game object set up? Alright, so we have the bullet, and then we have the light in here, and the Z-axis. Yes, actually what I'm going to do is I'm going to zoom in on this, and I'm going to game object create empty. So now I have an empty game object, and then I'm going to take this bullet and I'm going to drag and drop it on top of empty game object, and then I'm going to rename this bullet. Now the reason why I did that is because when we spawn this game object will be the center of where the bullet gets spawned. So that gives us the freedom of dragging the bullet forward and backwards, and that just will give us more control over what the bullet will look like as it comes out of the gun. So let's say the center is really back here, but then we have the bullet that you actually see in front of it, and then we can line it up better to make it look like the bullet is really coming out of the gun. So let's go ahead and take this and let's drag and drop it on top of this empty prefab bullet. So now we have that saved inside of here. So later on we'll add the script to this and save it inside of this prefab. And now let's try to find our shotgun again. I believe it's this one here. I guess it doesn't matter which shotgun I choose. And then I will take this bullet and then scroll down to where it says bullet and put it in there. And now it will know what game object to create for this line of code here. Now, the way I have it actually set up in this script, I have a for loop so that we can decide how many bullets we will create when we actually shoot. So I guess I will change the shotgun so that it only shoots one bullet straight forward as if it were like a pistol. So where is it? I believe it is shots per click. Yep, here we go. Shots per click. Oh, one. Oh, bullets per shot. That's what I meant. And right now I have it shooting 15 bullets. So I'm going to have it shoot just one bullet for now, just to make it make more sense and be easier to use. And now I'm going to hit apply so that all the shotguns in the game are going to have all of these new settings that I just created. So now let's create the script for our bullet. So let's go, I guess, inside of, let me make this window bigger. Inside of here where it says scripts, and I already have a bullet script, but I'm going to create a new bullet script. So I'm going to go to create JavaScript, and I don't know what to call it, new bullet script. Okay, doesn't really matter, you can call it whatever you want. Alright, and I'm going to double click to open it, and let's get started. So first of all, I want to get rid of pragma strict and function start. And then I'm just going to, I actually have dual monitors set up right now, so that's why my mouse is disappearing, and now I'm back, and I just copy and pasted some code. So let's go over the code that I just copy and pasted, and these are all the variables that we're going to be using in this episode in this script. So the first variable is speed, and this is pretty self-explanatory. This is how fast the bullet moves. And then we have a variable called random angle. Now, random angle is basically going to be the bullet itself is going to randomize itself in the way that it is pointing around in 3D space after the bullet has been instantiated or created. And then lifetime, basically this is just for if you shoot a bullet, say, into the sky and or like off of a cliff, and the bullet is going to just keep on going on and on forever. This is just meant to prevent that. So after 3 seconds, in this case, the bullet is going to kill itself, and then we won't have that bullet anymore, and it won't be taking up processing power and GPU power and all that cool stuff. And then we have bullet gravity, and this is going to be how fast the bullet drops down, and I have it set by default to 9.8 because in Unity I like to have the Unity units be meters because I think that's what it is by default based on the physics engine if you are on Earth. So the acceleration of a rigid body when you are on Earth is 9.8 meters per second squared. So that is why I have 9.8 set as this variable right here. So if we set this to a larger number, the bullet's going to drop down really fast. But if we have it set to, say, 0, it's just going to float straight forward normally. And then we have decal hit wall. So we're not going to be going over exactly how I created the game object that is the bullet holes and the particle effect when the bullet holes actually hit a wall. But basically, this is going to be a decal that we're going to throw over top of the wall. And I believe, let's see, let me check my code over here. I believe that we are going to have it match the rotation of the surface that it hits inside of this script. So instantiate point rotation. Yep, okay. So we're going to just instantiate a bullet that is going to, or I mean a bullet hole that is going to be rotated based on the wall that we hit. And that's going to be a prefab that we're going to save inside of this variable. And then we have a variable called float in front of wall. And this is going to be how far in front of the wall the bullet is going to basically float. And that is going to make it so that the bullet hole doesn't like interweave with the wall. So depending on your graphical quality settings and how far away you are from the bullet, sometimes if you have two meshes or two like planes that are kind of like laying over top of each other, you get this really jittery look and it looks really bad. So we're just going to make the bullet float just a little bit in front of the wall, so it still looks like it's a part of the wall, but really it's in front of the wall so that we always see the bullet and it looks nice. Alright, now we have two variables inside of here that are hidden in the inspector. And the first is move direction, and this is going to be a vector 3 that basically is just going to, it's going to be the equivalent of rigid body dot velocity. This is just going to be the direction that the bullet is moving and how fast it is moving, and we're going to manipulate this by bullet gravity for every frame and make the bullet move that way. And then we have a variable called shortest so far, and this variable is going to be used inside of a for loop that is going to determine basically if we're going to shoot a raycast, and if that raycast finds more than one hit, it's going to find the hit that is closest to where it raycasted from, so that way it won't appear on something that is, like if it hits two things, it might decide to appear on whatever is farther away from it, so the bullet could potentially go like shoot something through a wall. So this variable is meant to prevent that. And now the rest of these are also hidden in the inspector, and the first one we have is instantiate point, and this is a vector 3. And this is going to basically be a variable that we're going to use to figure out where we are going to instantiate this decal that we're going to be putting on the wall. And then we have instantiate rotation, and this is going to be the rotation that we are going to instantiate this decal on the wall. And then we have a variable called found hit, and we're going to be using this inside of the for loop. I think it actually would have made more sense to make found hit up here. That would have been more organized, but anyways, This is just a true and false variable to determine whether or not the raycast function has actually found a hit when we are for looping through all of the hits that we did find. And then we can determine based on the tag and let's see, let me look over here. Yeah, based on the tag and the shortest distance that we found so far, we're going to use the variable found hit just to keep things organized and use it to determine whether or not we found a hit. And then we have our last variable is parent to add, and this is basically going to make it so that if whatever the bullet hits is moving, so say like a rigid body or an enemy, it's going to save the decal that we create, and then we are going to use parent to add, and then we are going to make this have a parent so that after the bullet hole is created on the surface that we shoot, then it will stick to that, because then it will be a child of whatever that is, say a rigid body or enemy. So it actually looks like the bullet hole is really on whatever that thing is. Okay, I just talked a lot. Okay, just double checking to make sure I'm still recording. And oh crap. All right. There, okay. That is the problem when you have shortcut keys between multiple programs. All right, now I'm going to go over here and I'm going to copy and paste the awake function, and we're going to look at the things that we're going to be doing when the bullet is first created. So the first thing is function awake. So transform.rotation. Transform.rotate. So basically this is a function that is going to rotate our transform relative to where it is currently rotated. And what we're going to do is put inside of, so we have this right here is the X, Y, and Z that we are going to be rotating around. So first we're going to rotate around the X-axis. So this is the up and down rotation because it is rotating around the X-axis. So we have random.value, which gives us a random number in between 0 and 1, and then we're going to multiply that by 2, and then we are going to multiply that by random angle, and then we are going to minus random angle, and then basically this whole equation gives us a number that is randomly in between positive random angle and negative random angle. And then we are going to not rotate it around the y-axis, and then we are going to rotate it randomly between 0 and 360 around the z-axis. So now we have a random circle in which the bullet will randomly rotate. And now we are going to make move direction equal transform.forward times speed. So we're going to instantiate this bullet in the direction that we want the bullet to go. So we're going to use transform.forward, which is a vector 3 with a magnitude of 1, which represents the forward direction of our transform. And then when we multiply it by speed, now we have a vector 3 that is really big and representing the direction and speed in which we want the bullet to move. And then we are going to set variable shortest so far to mathf.infinity so that no matter what number we find, it will be smaller than infinity, because infinity is the largest number that you can conceive. And then we have found hit equals false, and this is just to double check and make sure that found hit is false, because it is pretty critical to have in the first frame found hit equal false. All right, now let's see. I'm going to try to figure out what part. I'm just going to copy and paste the whole thing. All right, so copy and put in here paste, and then I'm going to tab this over twice, and I'm actually going to select all of this, and then I believe it is inside of edit. Yeah, edit, format, indent selection. Nope, wrong way. Edit, format, unindent select, or Control Alt Home. So let's Control Alt Home. Oh crap, wrong line. I need to reselect all that. Control Alt home. Okay, there we go. Now the code is nice and clean looking. Okay, so the first line that we are going to go through inside of this script is transform.rotation equal quaternion.lookRotation move direction. Alright, so after the very first frame, we aren't going to modify move direction except for on gravity. So that's why we're using transform.rotation equal quaternion.lookRotation, because look rotation is a function that will return you a quaternion based on the vector 3 that you give it. So basically we want a quaternion that's going to look in the direction that we're moving. So as our bullet changes and as it arcs over and eventually goes all the way, or just arcs over and starts looking down, we just want the bullet to always look forward. Otherwise, it would look more like the bullet is sliding through space as opposed to flying through space. Now we have we're creating a variable called hits, and it is an array, as you can see, because of the two square brackets, and it is of type raycast hit. And then we have our next line of code, hits equals physics.raycastAll. Now physics.raycastAll is just like physics.raycast, except you can't use physics.raycast inside of an if statement. And raycastAll returns you an array of raycasts. So you need to save it inside of a variable that is an array. So our raycastAll is going to it's going to start at the origin position, and then it's going to be pointing in the direction transform.forward, and then it is going to be a ray that is of distance speed times time.delta time. Now the reason why we have speed times time.delta time is that we only want to raycast as far as we think that this bullet is going to move during the next frame. So we multiply speed by time.delta time because that is going to be the actual amount in which that bullet is going to move. And then now we are going to save all of the possible hits that might happen inside of this whole thing and save it inside of the variable hits. And now we have a for loop right here. Now the for loop is going to basically say for var hit in hits. So basically when you say var hit in hits, we are creating a variable for this for loop called hit. And we can access it anywhere inside of this for loop, and probably access it outside of the for loop if you wanted to, but in this case we are only accessing it inside of this for loop. And the variable hit is going to swap itself out with all of the hits inside of the variable hits inside of its array. So hit is going to be of type raycast hit, and hits is an array of raycast hits. So every time we go through the for loop, hit is going to be a different raycast hit that was returned by physics.raycastAll. And then the first thing we're going to do is we are going to test the tag of that hit that we hit. So hit.transform.tag equals level parts. So level parts is, in my particular game, is the tag that I have on all of the game objects that I want to be shootable by bullets, and just create a bullet hole if that bullet hits that wall or something like that. So we've determined that the tag is something that we want to use. So we have an if statement inside of that, and here is the actual condition for that if statement, and it is if vector3.distance between transform.position and hit.point is smaller than shortest so far. So we're measuring between the origin of the raycast and where the raycast actually found a hit, because that's hit.point is a vector 3, which represents in actual 3D world space where the raycast actually found a hit. So when we measure the distance between those two things, we know how far away that thing is that it hit, so that we don't actually go through the wall. And if it is smaller than shortest dist so far, then we are going to go through, well, I will explain. These are just for creating the bullet hole, but I want to explain this line first. Shortest dist so far equals vector3 dot distance between transform dot position and hit dot points. So that way, say if we go through this once, like let's say hits ends up after this line of code right here, let's say hits ends up being 2 hits long, like there are 2 things saved inside of the variable hits. So then we go through it the first time, and hits finds something that is 5 units away from the origin of the raycast. So then the second time we go through it, we find another hit, and it is 2 units away from the origin of the raycast. It will make sense to save it inside of the one that is 2 units away from the origin of the raycast, because otherwise then the bullet is just traveling through objects. So that is why we save that down here. And then we save the variable found hit equals true, so that we actually know that we found a hit, and if that is true, then we will run all of these lines of code here. And then the lines of code that I skipped are right here, and we are going to save inside of the variable instantiate point equals hit point plus hit dot normal times float in front of wall plus random dot range 0, comma 0.01. So the reason why we do all that is, first of all, we have hit dot point. So this is going to be the exact point that the raycast hit. And then we are going to add to it hit dot normal times, alright, so hit dot normal is going to be a vector3 that is going to, a magnitude vector that is pointing in the direction that the wall that you hit is facing. And then we are going to multiply that by float in front of wall, so that now we are adding a vector3 to this vector3, and when you add those 2 vector3s together, then we have the point floating in front of the wall just a little bit. And then I am adding random.range 0, comma 0.01. So now we basically have just a tiny bit of randomization in how far in front of the wall we are going to float. And the reason why we do that is because if we're shooting a ton of bullets on a flat wall, then all of the bullets are floating the same distance away from the wall. So then the bullets start interweaving with each other, and then you start getting that jittery effect between the bullet holes themselves. So this line helps to get rid of that a little bit. And then we have instantiate rotation equal quaternion dot look rotation hit dot normal. So basically we are turning hit dot normal into a quaternion using quaternion dot look rotation, because hit dot normal is a vector3 that represents a rotation, but the rotation that we need to instantiate an object has to be a quaternion, because we need quaternions for the transforms of objects. So we're just using quaternion.look rotation to convert that into a quaternion. Okay, so I think we got all of that covered. Now let's actually go down here and see what is inside of this if statement here. So the if statement is simply if found hit, which we have down here, found hit if we find any number of hits inside of this for loop. So we know that we have actually hit something. So we are going to, if this is true, we're going to create a variable called spawned bullet hole, and it is of type game object, and we're going to have it equal instantiate decal hit wall instantiate point instantiate rotation. So when we use the function instantiate like this and put it in front of variable equals instantiate, instantiate will return you the game object in which it just instantiated, and then we save it inside of this variable here. And then we have an if statement which says if parent to add. So just to double check to make sure that this line of code worked correctly. So if parent to add, spawned bullet hole, which is the variable which we just created, which saves the bullet hole in which we just spawned or instantiated, dot transform dot parent equals parent to add. So basically now our bullet hole is sticking to the game object that we shot. And then after that, we just destroy the game object because we don't need it anymore. So all of this happens if we actually hit something. And now we have these lines of code here, which are going to run regardless of whether or not the bullet has actually hit anything with its raycast. And the first thing is transform dot position plus equals move direction times time dot delta time. And this is basically just going to move our bullet in the direction of move direction at the speed which we defined and saved inside of move direction, and we're going to multiply it by time dot delta time so that it moves according to actual time and not the number of frames per second that your computer is running at. Then we are going to do move direction dot y minus equals bullet gravity times time dot delta time, and now we are manipulating move direction, and we're just manipulating the y, and we're just making it move down based on gravity. So now we're basically simulating gravity inside of our bullet. So these two things right here are pretty much how to add trajectory and bullet drop to your bullet. And then we have lifetime minus equal time dot delta time. If lifetime is smaller than 0, destroy game object. Basically, we're just creating a timer, and when that timer is all the way down, we're going to destroy the game object because we don't want it in the scene if it's just going to fly forever and just be annoying in that sense. Or not be annoying, I mean use up GPU and CPU power. Okay, so we got this script all set up and saved, so let's go ahead and go in here and let's go to our bullet and let's add the new bullet script to our actual bullet. And then, whoops, I have my keys, pressing the wrong keys. Okay, and now we want the actual bullet hole, so let me find it. I believe bullet holes, bullet hole. Okay, that's what I wanted. Alright, and let's see, do we need to set anything else? For now, I think that will work. So I'm going to select apply, and I think that will work. Let's go ahead and give the game a run. So I'm going to click play and then cut the video so that you guys don't have to wait for it to load. Alright, the game has loaded, and let's see if it works. Oops. It looks like it's working. So the shotgun is shooting one bullet, and it looks like the bullet that we created. And as you can see, when I shoot something really... Let me reload, okay. Alright, when I shoot something really close, there, now you can see it. You can see how the bullet is kind of not quite in the spot that we want. And I guess there's the glitchy effect that you can see. As I get farther away, it increases. So we probably want to increase the variable float in front of wall. So as I get closer, you can see they don't quite glitch up as much, but they do still glitch up. So the way to fix that is to just increase the variable float in front of wall, and the bullets are, or the bullet holes are destroying themselves because of a different script. But yes, so in order to make this look better, we can just adjust the different variables, and then we can adjust the local Z position of the gun in case you want to spawn slightly differently. And you can see the actual, let's see if you can see it a little better, the lights of the bullet actually lighting up the level. I think the bullets are moving just a little bit too fast. I would turn them down for myself, but let's try shooting through this wall. So if I'm just going to clip the corner of this wall, and as you can see, every single time it actually hits this wall. And then one other test I'm going to do, I am really close to this wall right now, and technically my gun is going through the wall, but because I used a camera trick, it makes it look like the gun isn't going through the wall. But even when I shoot, let's see if I can see the bullet hole, there it is, the bullet doesn't actually go through the wall. So like I can, whoops, crouch to the ground and the same thing happens. So I can't shoot through walls. Alright, I think that's everything that we need to go over in this episode. So until my next episode, I'll see you guys later, and keep making games.